Greetings everyone and welcome to SpaceWeek Live on this Sunday, April 24th, 2022. You know what? Bennu is actually paying me a rare visit during SpaceWeek, so let me try to rotate him into view. Hopefully he doesn't get up. Hey buddy. Thank you. Okay. Normally he's not here in the room with me when I do this, so yes. Welcome once again to another round of What the Heck Happened This Week. All right, so last week wasn't quite as busy as we were anticipating because there were a couple of delays, but let's take a look at what did happen. All right. So last Monday, cosmonauts Oleg Artemyev and Denis Matveyev had a very productive spacewalk outside the Russian segment of the ISS, preparing the mounting location for the European robotic arm, amongst other things. This is a little sped up video, but yeah, they got everything done that they were supposed to, plus some. The European robotic arm, of course, was delivered to the space station on the new laboratory module, whose name escapes me at the moment, but the new laboratory module that was delivered after a 14-year delay last fall, I guess it was. And they've been conducting a series of spacewalks to prepare that laboratory module for use. Now this one was, of course, to prepare the site for the attachment of the European robotic arm, which will perform a similar function to the Canadarm2, which is the robotic arm on the American side of the space station. The Canadarm2 cannot reach over to the Russian side. It's not compatible with the Russian mounting hardware, and so they will finally be getting their own robotic arm. Now, up until now, they have had the Strela boom, which is like a 40-foot long boom that allowed them to, maneuver around on the Russian side, but it wasn't a fully articulated robotic arm with manipulator attachment on the end like the Canadarm2 that we're accustomed to. So congratulations to them on getting all that done. Let's see. On Friday, NASA's Jet Propulsion Laboratory released a video from the Mars Perseverance rover showing a giant potato crossing in front of the sun. Was it a giant space potato? No, of course. Of course not. It was the Martian moon Phobos, which is a small moon and very oddly shaped because it does not have enough gravity to compress itself into a sphere. And so here we see Phobos moving across the sun. Now, the dark splotches you see on the sun are, of course, sunspots. See, I was not aware that Perseverance either had a camera with a sun filter, because normally the sun is exceedingly bright. Let me stop it here in the middle. Normally the sun is exceedingly bright and you need a very strong filter to take any photos or to look at it. But so I was not aware that Perseverance had a camera with a sun filter. I also was not aware that it had a camera capable of taking such high-resolution images of the sun. Now, we think of the sun as being large in our sky, but it's actually only about 1/2 degree, so about the same as the moon, which is why the moon just barely covers the sun. The sun is 400 times bigger in diameter than the moon, but the moon is 400 times closer to the Earth than the sun. So that's that special relationship. approximately. Of course, Earth's orbit around the sun is not quite perfectly circular, as is the moon's orbit around the Earth not quite perfectly circular. So in any case, the sunspots represent cooler regions of the photosphere, the outermost layer of the sun, before you get to the corona. And so what we see here is a Martian eclipse, as it were. Now, there's been some debate as to whether this should be called an eclipse, because Phobos, being a small object orbiting close to Mars, isn't capable of fully covering the sun. And so should they call it an eclipse? Well, or a transit. So, for example, when you see Venus or Mercury passing in front of the sun, that's called a transit, not an eclipse. But I would argue that because Phobos is a moon, now I don't know what the official definition is, but I would argue that because Phobos is a moon of Mars, and it is in fact passing between Mars and our sun, that this could be correctly called an annular eclipse, just like we have annular eclipses on Earth, which is a ring of fire eclipse where the moon doesn't quite fully cover the sun. The difference being that our moon covers much more of the sun than Phobos does here. But all of that is sort of a matter of semantics, and whether you call it an eclipse or a transit, it is still really quite cool. And so there you go. Thanks to the Jet Propulsion Laboratory for that. Then on Thursday, actually, there was a SpaceX launch of another batch of Starlink satellites. Let's check it out.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition, and liftoff of Starlink 414. Vehicles pitching downrange.
So you may notice the cloud cover there. It was a pretty cloudy day there in Florida, and that was also true 100 odd miles off the coast where the booster came back down, because we got a pretty dramatic. Oh, here we go. Here's the rocket ascending through the clouds.
Falcon 9 has successfully lifted off from Space Launch Complex.
And we had a pretty dramatic view of the landing. Not perfect coverage, but pretty close. So let's check it out.
Through the clouds now. Everything continues to look nominal with second stage there.
Landing burn. Stage 2 terminal guidance.
All right, we heard the call out and can see there on screen the landing burn has begun. Watch closely, we should be able to see the drone ship come into view. This drone ship is about the size of a football field.
Stage 1 landing leg deploy.
As you can see, this booster has touched down.
Boop. And somebody commented during the stream that those landing legs must be pretty tough to, because they take a beating. But yes, for sure, some robust hydraulics in there. And there was not coverage, or there was not live video from the deployment of the satellites, which they had anticipated, so they ended the broadcast early. But yeah, so that is all for last week. Now, taking a look even further back at space history, we are, of course, in the middle of the 50th anniversary of Apollo 16. Astronauts John Young, Ken Mattingly, and Charles Duke launched on April 16th and splashed back down on April 27th, 1972. And the 27th is on Wednesday, I guess. Is that correct? It is Wednesday for us. So yes, that'll mark the 50th anniversary of Apollo 16, the penultimate Apollo mission. Apollo 17, of course, was the last and the last time that humans were on the moon. Now, looking ahead to this week, oh, there was one other thing I forgot to mention. Let me go back here. The Tianzhu 3 cargo craft was relocated to the opposite side of the Chinese space station. You can see here a diagram of the maneuver. It exited off of what we're seeing here, the left side, circled around, big arc, and then docked to the right side. And there's a short animation, but then we actually get to see the approach. The video of the approach, I should say. Here we go. And so we don't get a ton of news out of the Chinese space program, aside from just a procession of launches. But there you go. Successful relocation of the Tianzhu 3 module, or spacecraft. All right, so looking ahead to this week, tonight, April 24th, with coverage starting at 6:30 p.m. Eastern, 22:30 UTC, the 4 Axiom-1 crew members will finally return from the International Space Station after 15 days in orbit. They had only planned to stay for 10 days, but there's been bad weather in the recovery area off the Florida coast, as is pretty normal for Florida, and so they've been delayed for 5 days thus far. Now, I had heard a rumor that they may be delaying further, so be prepared for that. But for the time being, coverage will begin 6:30 p.m. Eastern, 22:30 UTC, with the hatch closing about 20 minutes later. Then a couple hours later is the undocking, that's starting at 8:30 p.m. Eastern, 0030 UTC, with the actual undocking about 25 minutes after that. Now, unlike NASA's crew missions, Crew 1, Crew 2, etc., where there is continuous coverage from launch to docking and then from undocking to splashdown, there will not be continuous coverage of the Axiom-1 undocking to splashdown. I'm expecting there to be coverage from SpaceX of the splashdown, which I will bring you once that schedule becomes available. I'll bring you a live stream of it on this channel. But we're not going to see the intervening hours as we do with the NASA missions. So there you go. Now, the splashdown should be, let's see, the splashdown should be on Monday morning at some point. I'm not sure exactly what the schedule is for splashdown, but once I'm aware of the schedule from SpaceX, I will put it up on the Raw Space calendar, which I will link in the chat, and I'll also create a live stream, prepare a live stream for you. So on Tuesday, April 26th, and I don't have it on this calendar here because I didn't update it, but on Tuesday, April 26th at 11:30 p.m. Eastern, 0330 UTC on the 27th, a Long March 11H will launch from an ocean-going platform off the Chinese coast with 7 small Jilin-1 high-resolution imaging satellites. And, oh, I do have it on here. I just need to scroll down. There it is. Because it's at the very end of the day. So, yes, no live coverage of that, but the sea-based launches are always pretty cool to watch. All right, after the fact, in any case. Then early on Wednesday, starting at midnight Eastern, 0400 UTC, begins continuous coverage of the launch through docking of the Crew 4 mission. So on board will be NASA astronauts Kjell Lindgren, Robert Hines, and Jessica Watkins, as well as European Space Agency astronaut Samantha Cristoforetti, to begin their 6-month expedition on the ISS. Now the coverage begins at midnight, but the launch isn't until 3:52 a.m. Eastern, or 07:52 UTC. Then there will be a news conference an hour and a half later-ish, and if they hold to their original schedule from last week, because it was delayed due to weather, the launch was delayed by a few days, then I'm expecting the docking to be at approximately 5 a.m. Eastern, 0900 UTC on the 28th. But again, I don't have confirmation from NASA on the schedule for docking, only that there will be continuous coverage. But it's going to be a sort of a long, slow flight, as has become the norm for Crew Dragon launches. And I don't honestly know why they have to be quite so long. I mean, even if they can't make it to the space station in 3 hours like Soyuz can, I'm not sure why it has to take almost a full day. Maybe because of their operations schedule, they have to squeeze in a sleep cycle, which adds a large number of hours. Who knows? But in any case, we have that to look forward to. And let's see. Later that same day, at 5. This is on Wednesday at 5:30 p.m. Eastern, 21:30 UTC. Is Rocket Lab's big day. There and Back Again will launch with the first attempted mid-air catch of the Electron rocket's first stage booster. So on board will be 34 commercial payloads for various companies, and and so hopefully we'll get to be able to watch their helicopter catch of the booster as it comes down. As I mentioned last week, they have splashed down a couple of boosters previously, with and in at least one case, there was the helicopter sort of hovering nearby because they were simulating a catch without actually catching it, but they have not actually attempted to catch it yet. So now they have dropped it from a helicopter. I'm pretty sure, but I think they dropped it from a helicopter, but they haven't caught it. So that'll be cool to see. This will be only the second orbital class booster ever to have a controlled recovery. That is not a splashdown or whatever, or just burning up. So this will be only the second orbital class booster in the world that will have ever had a controlled recovery. Of course, the first is Falcon 9, with their numerous booster landings. Then on Friday at 8 p.m., good heavens, that's not correct. Thursday, I skipped something, yes. On Thursday, April 28th, starting at 10 a.m. Eastern, 1400 UTC, is another Russian spacewalk with cosmonauts Artemyev and Matveyev. They're continuing to work on the Nauka module, which is the name I couldn't remember earlier. Actually, they may be working on Nauka. They may also be working on the mounting of that European robotic arm. But all right. Then Friday, April 29th at approximately 3 p.m. Eastern, 1900 UTC, SpaceX will launch Starlink 4-16 from Cape Canaveral. Also on Friday, at 8 p.m. Eastern, midnight UTC, there may be a Chinese Kuaizhou launch with the Centispace 1 S3 satellite. which will test global navigation satellite system augmentation techniques, including a laser intersatellite communication link. So GNSS, Global Navigation Satellite System, is of course the generic term for a global constellation of navigation satellites, of which GPS is one. There are others. China has one, Europe has one, Russia has one. But yes, a GNSS is the generic term for what we usually call GPS. And laser intersatellite communications links, of course, are a much advertised feature of the latest generation of Starlink satellites from SpaceX. Then, and this goes there's a partial solar eclipse. So the new moon is this Saturday, April 30th. And of course, solar eclipses always happen during a new moon. So there will be a partial solar eclipse visible from some areas. I don't have a map for you, but now that you're aware of it, you can look it up. So this is, I presume these times are UTC, 4:28 p.m. or 16:28 UTC, partial solar eclipse on Saturday. And please do look it up to confirm the time and locations, because I'm not sure where that partial eclipse will be visible from. And because I didn't specifically say the time zone here, I could be 4 hours off. This could be 4:28 p.m. Eastern time, in which case it would be 20:28 UTC. So again, look that up to confirm the time. But again, you're aware of it now, so run with that. Then next Sunday, May 1st, at a time to be determined, Russia might be launching their Angara 1.2 rocket from far northern Plesetsk Cosmodrome with the small MKA-R military radar satellite. This would be the first orbital launch attempt for Angara 1.2. Of course, there's no live coverage for Russian military launches, but we should be able to see the launch after the fact. Yeah, probably not in next week's SpaceWeek, but likely the week after, because the video will have been released by then. All right, so I want to take a moment to thank our channel members and supporters for casting their vote for this sort of content. Your contributions are much appreciated, of course. And all right, let me get to your questions. So these questions should have been automatically yes. All right, so 1:39 p.m. today. Okay. So if you did not tag raw space while asking your questions, then I may not get to them here. So if you didn't tag my name earlier, you may want to ask again. But I will answer what we've got. All right, so Chris V said great landing footage of the Falcon. That was great landing footage. Would have been nice if we didn't have the lag, like it because of the jostling of from the landing burn. We didn't get totally smooth video, but it was dramatic footage in any case. All right. Philip Davis asks when they are going to make an electromagnet spacecraft to pick up debris and turn electricity off to burn in the orbit, then land as normal. Electromagnet spacecraft to pick up debris. So the main problem with recovering space debris, space junk, bits of material in orbit, is that it's traveling really, really fast, 17,500 miles per hour in low Earth orbit. And in order to rendezvous with any object that is in orbit, you have to match its orbit. Otherwise, you're going to be going really fast relative to that object, whether you're coming at it, sideways, like you're going to T-bone the thing, or head on. I mean, you could have a potential impact with space debris at up to more than what 34,000 miles per hour if you hit it head on. I mean, that is a huge amount of momentum energy, kinetic energy from that impact. And that, and if it's a sizable object, like a pebble or a chunk of spacecraft or something, that's going to have the kinetic energy of like a grenade or a bomb. I mean, so electromagnetic garbage collection in space. I mean, electromagnets are useful, but it's going to get like pummeled before its electromagnetic field has the opportunity to grab anything. Like you'd have a better time collecting space junk by literally ramming it with some sort of craft that's designed to absorb the impact than you would with magnets or anything like that. And you would also, need to you need to get to it, so you'd need to either match its orbit or intersect with its orbit somehow. But space junk is a tricky problem. I mean, in low orbits, it's perhaps less of a concern because there is atmospheric drag from the tenuous upper atmosphere that causes objects to naturally deorbit after a period of years. But it's still a tough nut to crack. And so I don't think that electromagnetism is the answer or is a viable solution for cleaning up space junk. I could be wrong, but I don't. My layman's knowledge of electromagnetics and orbital mechanics suggests that's not a feasible solution. But maybe using some sort of ground-based lasers to like push the debris in a like slow it down or speed it up in such a way that it encounters more atmospheric molecules and deorbits quicker. I don't know, but space junk is a tricky problem. It wouldn't be so bad except everything up there is moving incredibly fast and in its own direction. So like any force that you can apply to it will be minuscule compared to the kinetic energy the object has traveling so fast around the Earth. All right. Ross, this is from Iwo Wisniewski. Do Chinese cargo spacecraft burn up like the Russian cargo spacecraft? In fact, all cargo spacecraft in the world, except for Cargo Dragon, burn up on re-entry. So Cygnus and the HTV from Japan and Progress from Russia, yes, all and Tianzhu from China, every cargo craft in the world except for Cargo Dragon does burn up on re-entry. So until somebody else develops a recoverable cargo craft, that will remain a universal truth except for SpaceX, because they designed their systems from the ground up to be at least partially reusable and fully reusable for the capsules, the Dragon 1 cargo and the Dragon 2 crew and cargo. MVM Motovlog Music. Will Rocket Labs try to helicatch the booster in the next launch? Yes, they will, as I mentioned earlier. That'll be exciting to see. Hopefully all goes well. It's a crazy thing to try, but so is landing a booster on a drone ship. So go Rocket Labs. MVM Motovlog Music again. Ha! Ross Base, thanks for answering my question. Oh, you're welcome for answering. See, these are not curated questions. These are automatically regurgitated questions. We have a script that pulls anytime somebody tags my name. So I should read the question before I answer it because it might be superfluous or whatever. All right. Chris V asked by one Idiotus. Is that the person's name? I don't know. But if that is your name, okay. The Crew 4 going to be on an East Coast trajectory for launch like it was supposed to be earlier. I suspect their launch trajectory will be the same as was previously planned, just at a different time. But I don't specifically know. I'd have to do some research, look it up. There are websites where you can look up the trajectories of launches, sometimes before they happen. And, you know, I'd have to look it up, which you can also do as well if you wish. But I don't specifically know, no. I mean, maybe if I lived in Florida, you know, and was a launch watcher, I would have that in my pocket. One Last Idiot. Okay. All right. Thank you. One Last Idiot is the person's name. Nice name. But you should give yourself some more respect. All right. Peter Cortons. Is SpaceX close to its maximum capacity of Falcon launches with its current production plus launch facilities? So, I thought it was interesting when the Ukraine Starlink thing was going on, when SpaceX delivered a bunch of Starlink terminals to Ukraine, some of which were donated, some of which were paid for, but I know there was some discussion of that. But Elon Musk had tweeted that SpaceX was going to divert some of their focus to, I guess, hardening techniques for ensuring that Starlink doesn't get hacked and or you know, signal blocked or whatever, and jammed. Yeah. I thought that was interesting because the implication was that they were reallocating existing human resources to this problem as opposed to, you know, bringing in additional people or whatever. So, you know, if SpaceX is a zero-sum game, that is, they're not in a hiring frenzy, nor are they in a downsizing, then have they reached their maximum capacity of Falcon launches? Probably not. There are always additional efficiencies that can be realized, and they're quite a well-oiled machine. I mean, they have a launch cadence unmatched by any other launch provider in the world. But you know, I would say they may be approaching their maximum capacity without adding additional personnel and facilities to ramp up production. But with the reuse of, like, they have I think a couple of boosters now that have flown 12 times. With the reuse of the boosters, the manufacturing is doesn't have to happen at a particularly rapid pace, although manufacturing of Starlink descending down through their own exhaust plume. All right. Wafikiri. Why do I get that wrong every time? Wafikiri. Shouldn't can crusher stands have different adapter rings for different booster perimeter geometries, thus sharing most of the stand? Can crusher stands adapter rings different booster perimeter geometries. So I'm not sure what Can Crusher is referring to. Are you talking about the launch stand for rockets? I'm not sure where this came from, but that's some sort of slang there that I'm not familiar with. Maybe it's a nerdalism. I'm not sure, but yeah, having modular or adaptable or universally compatible hardware and facilities is greatly beneficial for sure. I mean, you know, you I prefer to go the way of Linux than the way of Apple as far as you know, proprietary systems that are only compatible with each other. All right, MVM Motovlog Music. Have you heard anything regarding Dear Moon? Seems as though no one is mentioning it anymore. Well, it certainly hasn't been in the news. So Dear Moon, of course, was the circumlunar mission that was planned for Starship once that vehicle was ready, with Yusaku Maezawa and his pantheon of artists. But I haven't heard anything new about it. Obviously, Dear Moon is completely dependent upon the development of Starship and Super Heavy, and the Starship Super Heavy stack. And you know, they've been very busy down in Boca Chica, but there haven't been any launches for a while, any test launches. We're still awaiting our first orbital test launch, and hopefully that's coming soon. But we've been saying that again for a while, so you know, maybe Elon Musk really did divert a bunch of effort from Starship development to Starlink digital hardening. I don't know. It seems like you'd have entirely different fields of expertise at play there, but what do I know? I'm just a dude. But yeah, so once we see Starship finally conduct an orbital launch, a successful orbital launch, and that, I think, is when we'll start hearing about Dear Moon again. Because until Starship is going into orbit, Dear Moon is just a dream. Just one crazy man's dream. And so that's my theory. But yes, there's basically no Dear Moon without an orbital Starship. So look for Starship news, and then we'll start hearing about Dear Moon. And the lunar Starship, which will be, which is contracted to be used in the Artemis program. Both are entirely dependent on Starship development. All right, Wafikiri again. Okay, so Can Crusher stands equals structural test stands. Okay, so generally speaking, I'm a big proponent of reusable systems or adaptable systems, or systems that can be used with different vehicles, different whatever, because it makes them more useful, and I love adapters. But I don't specifically have any domain knowledge of you know, the mounting hardware of structural test stands. So, all right. Chris V, thank you for your show of support. All right. So now I have finished with the queued questions. Mark Desire says, I'm starting to wonder what is first in space, Starship or SLS? Well, yeah, because SLS was supposed to, I mean, they've been having issues with their wet dress rehearsal, with mostly with the ground equipment, but with the mobile launch platform. But yeah, it's quite possible that SLS may get to orbit before Starship does. Think of it as a race. Light a fire under some of these slackers. I'm kidding, of course. Rockin' Robin says orbital refueling will be the next landable booster, a breakthrough that's necessary for space exploration to accelerate. I would tend to agree, because launching fuel is the most expensive thing we do. Most of a rocket is fuel. The rocket itself is not that terribly heavy, but the fuel needed to launch the fuel adds up to many, many tons. And so, yes, being able to refuel on orbit will allow us to fill spaceships with enough fuel for their long interplanetary journeys. Benu's still curled up in his chair, in his bed. Let's see. Yazata says Eric Berger thinks less than 50% chance of orbital Starship launch in 2022. That is possible, considering how quiet things have been in terms of launch projections from Boca Chica, but we shall see. You know, I'm not a big... speculation can drive views. It certainly drives news, but I'm not a big fan of speculation because, in the end, nobody knows. You know, I mean, they can have, unless a projection is announced, then all we have is guesswork. All right. Okie dokie. So also I want to take a moment to congratulate our dear friend and longtime moderator and channel member, Microbyte, for reaching retirement after a long and fruitful career working on machines and lasers. So congratulations, and we're glad to have shared this very small bit of your journey with you these past few years. But all right, so that will wrap it up for this week. Sorry if this was a little bit meandering. I've not been feeling very well, so I was a little less prepared maybe than I should have been. But thank you for coming, and I hope to see you in the next live stream. Until then, keep it raw and say hi to Benu.